Hello, this is week 6 of construction print reading. This week we're going to talk about framing, that is the structure above the ground. We have cleared our site, we have built the foundation. Now we start raising the structure. What kind of framing? Framing is the floor, the walls. And there are two types of walls that we have to consider. There are the load-bearing walls. Those are the ones that carry the load. Sometimes they might be known as bearing partitions. And then there is non-load-bearing walls. They carry no load and they simply divide space. And that's important when you're building or remodeling. And then there is the ceiling. The ceiling can form the floor of the second level or levels above it, or can be part of the roof. Let's take a moment to look at the evolution of the light frame construction. Originally, construction made use of thick masonry walls, heavy timber posts and beams, and thick plank floors and roofs. It required the use of something called joinery, making connections without the use of nails or screws, which required the use of expert craftsmen. So the wood light frame system was invented to replace this heavy construction, and when it first appeared, it was known as the balloon frame. And it coincided with the mass production of nails and consisted of thin, closely spaced vertical wood members, which we today call studs, and roof and floor framing members that are called joists and rafters. The benefit was that it could be erected by a relatively unskilled crew of 2 or 3 people, eliminating the need for the expert craftsman. Now, the balloon frame, the floor, the roof, the wall framing are completed for the entire building before the structural floor, which is referred to as the subfloor or floor sheathing, is constructed. The platform frame, which superseded the balloon frame, the subfloor at the first level is completed after laying the joists at that level, and that subfloor then provides a platform for workers to stand on and build the following story, hence the name platform framing. So the balloon framing is multi-story. A single piece of lumber will be the vertical studs for at least 2 stories. Platform framing, on the other hand, each floor is built as a unit, and the second floor or succeeding floors are not built until the previous floor is completed. Today, the most common type of light framing is platform framing, and the members are made up of wood, which is used because it is less expensive. Sometimes those framing members might be metal because they can add to fire resistance. So in summary, the types of materials we will use for framing will be wood, either dimension lumber or engineered lumber, or metal in the form of light gauge cold form steel or hot rolled structural sections. When we're dealing with dimension lumber, we're talking with solid sawn standard sized elements. They are identified by the wood species, meaning the tree of origin, the grade, the quality of the wood, the size, the classification of the usage, and the authority that has provided this grading. That grading might be based on information from the National Design Specification for Wood Construction, or the American Institute for Timber Construction, or various trade associations such as the Western Wood Products Association, West Coast Lumber Inspection Bureau, or the Southern Pine Inspection Bureau. And they will produce information about the type of wood, the size and the use and allowable stresses under certain conditions. So when we're dealing with lumber, the maximum length for a single piece is about 24 feet. If I need to have a longer piece of support, I either have to provide an intermediate support or I have to turn to something called engineered lumber. And this is a built-up section that is glued and laminated and can span great distances and great loads, much greater than can be supported by dimensional lumber. And you will see this often referred to as glue lam. Now, dimensional lumber has what are known as nominal sizes. So that raises the question, is a 2x10 really 2 inches by 10 inches? The answer is no. As you can see, softwood dimensional lumber sizes, a nominal 2x4, what we always find over in Lowe's or Home Depot, is actually 1.5 inches thick by 3.5 inches wide. And for the most part, until we get past 6 inches, the difference is about 1/2 an inch. When we get to 8, 10, and 12 inches, it's actually 3/4 of an inch in terms of width. Thickness is always 1/2 inch or 1/4 inch smaller than nominal sizes. When we're dealing with metal, we might be using what are called rolled sections. These are developed by hot rolling steel through a series of rollers until the desired shape is achieved. And this creates the familiar cross-sectional forms, which we call shapes, American Standard I-beams, today known as S-beams, W-shapes, originally called wide flange shapes, and various other structural steel shapes. It also can be used as light gauge sections, and these are sections that are formed from thin sheet steel, and they are cold formed. That is, they are formed without heating and softening the material as in hot rolling. So here are some of the typical hot rolled shapes. So here is the S, once upon a time known as an I-beam, the S section and W section. They are very similar, and I'll show you the differences shortly. The channel section, angle, pipes, hollow tubes, bars, or plates. The T section is essentially an S section or W section that is split right down the middle. Now, here's the comparison between W and S shape sections. They both resemble each other, except the S section, the bottom and top flanges are tapered as opposed to being straight, with rounded edges rather than sharp edges. And the flanges tend to be wider in the W shape, hence their original name of wide flange, than the S shape. But otherwise, they tend to be very, very similar. And in W-shaped dimensions, you can see the various different sizes. The depth will vary. The thickness of the web, the thickness of the flange, the width of the flange. And depending upon where they are placed, these sizes will vary. And you will see in some of the drawings where we call for W shapes. Cold form steel or light gauge steel members are made from thin sheets of steel by bending the sheets to various profiles at room temperature, and that's why they're called cold formed, and they are abbreviated by the words CFS for cold formed steel. Here are some examples. These are studs, cold formed studs, and there are cutouts so that electrical or plumbing lines can move through them, and there are varying depths and widths of stud and flange. And this is usually the application for these metal studs. Also as a framing member are steel joists and joist girders. Now, these are based on standards that are put out by the Steel Joist Institute, and they're produced with either hot rolled or cold formed elements combined. And the Steel Joist Institute will classify them into three categories: K series, which are 8 to 30 inches in depth; LH series, which are 18 to 48 inches in depth; and DLH series, which will range from 52 to 72 inches in depth. And this is what a steel joist or joist girder will look like. Now, let's take a look at some of the drawings in the text and in the handouts and see what we are to be looking for in terms of framing. We're going to start with the brick veneer residence sheet number 5. And you can see here the floor framing plan, and I want to call out this section here where we're asking for 2 by 10s times 14 feet, 16 inches on center. We're looking for a piece of lumber, a nominal 2 inches by 10 inches. In reality, it's 1.5 inches thick and 9 1/4 inches wide. They are 14 feet long and they are 16 inches apart. In this area, we also have 2 by 10s, but in this one particular area, they are 12 inches on center, 12 inches apart. So they are closer than they are here, and we'll talk about that in a minute. And over here, we have 2 by 10s back to 14 feet long, 16 inches on center. Notice it calls for the 8-inch wide flange beam, and this runs down the center of the basement, and these wood joists rest on the beam. Now, why is that? Well, as you recall, we just talked that the maximum limit for a single piece of dimensional lumber is about 24 feet. And we know from prior discussion and assignments that the distance from here to here is about 29 feet. You can see with 2 by 10s at 14 feet, across would be 28 feet. So I can't have a single joist going across here. And so we have a joist from the foundation wall here to this steel beam. So it only has to support this half of the floor. there's another beam that supports this half of the floor. It's a way to get around the limitation on the length, but also, if it were a single piece, it would be supporting a much greater load, and I'd either have to use a bigger joist or I'd have to put them closer together. So let's take a look at this and see why it needs to be closer together. Obviously, it is probably because of a greater load. Now, what load can we be talking about? Well, here is the floor plan of everything that is going to be sitting on this floor, which we'll talk about in later presentations. But for now, I want to show you what is sitting over this area. If you notice, it is the 2 bathrooms. So you take the weight of a 5-foot tub and the weight of all the bathroom appliances, and consider that this tub could be filled with water at roughly 6.5 pounds per gallon, as well as the homeowner who might be sitting or standing in it. Hence the reason for the need for greater structural support. In this particular case, they maintained the 2x10 joists, but by moving them closer together, each joist doesn't have to support as much weight. Therefore, overall, it can support a greater weight. Now, if we take a look at the floor plan from Brick Veneer 1, we see in the carport this call out for a wide flange beam, and that tells us that we want a W12 by 27 across the opening of the carport. Why? Because for a 12-inch deep beam, this would have a greater load carrying capability than a timber joist for this very long open span. Turning our attention to Brick Veneer 3, I want to point out some information found on section AA and detail number 2. In section AA, we can see the W8 by 17 wide flange beams and the 2x10s that are across it. Recall, we were looking at a plan view, and these W8s were running in this direction and the 2x10s were running across. We're now seeing it as a section through the house looking towards the bedrooms. In detail 2, we see the 12-inch wide flange beam that is being used at the carport entrance. And together with the information on Brick Veneer Sheet 1, we know that this will be a 12-inch wide flange beam, or W shape, that's 27 pounds per foot. Looking at Commercial Building Sheet A1 found in your handouts, we have a cutting plane here, cutting plane number 2, that extends to this location, and because of which direction these arrows are facing, we are looking in this direction. Down here we have cutting plane number 1, and again we are looking in this direction. Notice that down here is also a cutting plane number 1. So if we now turn to sheet A2 of the commercial building, we will see rear section, stair section 2-2 and section 1-1. Notice it includes both the first and the second floor. So let's look at some of the framing. Here's section 2-2. Notice 2x4s are called for 12 inches on center above the stairwell. A channel, that's what this symbol means, a channel 12 inches deep, 20.7 pounds per foot, rests on the outside wall. Section 1.1, here's our channel again. We have an angle 4 inch by 4 inch by 5/16 inch continuously welded to the channel. I have 2x10s 16 inches on center. I have a wide flange beam here and here, a W12 by 26, and I have another wide flange beam here, a W14 by 34. Notice the leader pointing to it. 1/2 inch gypsum board. This indicates that all this area is 1/2 inch gypsum board. So building brick. So these are the uses of, remember in the very first presentation we talked about leaders pointing to things in the drawing. But where are these located? For that we have to go back to sheet 1 and we look at the first floor plan, and it tells us that our W14s by 34 are 13 feet 10 inches on center. Going to the second floor plan, we see our W12 by 26 W-shaped beam is 17 feet 0 inches on center. So loads are different on the roof than they are on the first floor ceiling. Let's take a look at note number 1. It tells us that all partitions that are not dimensioned will be 3.5 inch wood studs. It does go on to say metal studs may be used, but all dimensions must be adjusted. Remember, earlier we talked that wood framing tends to be less expensive, but metal studs are often substituted for greater fire resistance. But what this note is reminding us is that the width of a metal stud is often 3 5/8 inches rather than 3.5. So all your interior or exterior dimensions will be 1/8 of an inch off. So that's what this is telling us, to keep that in mind. It also tells us in note number 2 to provide blocking as required in frame walls. And that brings us to the note by room 102, which says that grab bars in restrooms are provided and installed by the general contractor. We'll talk a little bit more about being provided and installed by whom later. But it does say to provide 2x6 blocking as required for support. And what are they talking about? Well, here is a view of a project I did about 10-15 years ago to a shower stall, and foreseeing the day when I might be infirm enough to require grab bars, I installed blocking so that there would be something solid to connect the grab bars to at that later date. And that's what this note is referring to. Turning to Wendy's sheet 7A, I want to draw your attention to this section here, section B, here it is a little larger. And where does this section come from? We have to go back to sheet 4, and we see that section B is cut through the freezer and the wall into the restaurant space looking towards the outside of the building. So you can see here, cooler freezer box is defined here, and we have fiber reinforced plastic wall paneling. We have interior finishes in here. So we are looking through the wall and we can see the section. Here's our 2x6 blocking, 4-inch block veneer rather. Notice the joist that is shown supporting the roof. On Wendy's sheet 7B, want to look at section H and section G, and here they are in greater detail. And again, going back to sheet 4, we can see where the cutting plane is, the direction it is looking, and therefore we can orient ourselves with this section on sheet 7B. Notice this is the pickup window, the sliding window, and when we look at G, we can tell from comparing it to sheet 4 that the outside of the building is on my left-hand side. Here are 2x10s with 2 half-inch plywood fillers, which were often used to make up the difference from the width of dimensional lumber to the thickness. Since a 2x10 is 1.5 inches thick, 3 of them would be 4.5 inches thick, and when I add in 2 half-inch plywood fillers, I wind up with a unit that is 5.5 inches thick, which is the same width as a 2x6, and so they will match. Section H is similar. When I look through it, the inside of the building is on my right-hand side, the outside of my building is on the left-hand side, and you can see the types of materials. When we talk about finishes, we'll talk about them in more detail. But again, here's a plywood header made up of 2x10s and plywood fillers. On 7B, we see sections F and E, my enlargements, and we see that F and E are taken on the opposite side of the building, and in this case, the outside of the building is on my right, the inside of the building is on my left. So whenever you need to know what the inside of a wall looks like, you will look for sections. Finally, we want to look at sheet 8 of Wendy's. Specifically this area here, which is showing the joists that are used to support the roof. A T4A, a T2, and a T2A. Now, how do we determine what that is asking us? Notice it says 5 are required, 3 are required, 8 are required. We turn to this area up here with the material when we look at the material list and engineering specs, we see T4A called out, 5 required. T2 called out, 3 required. This is a TJI L90. This is a T4A or LPI 56. We also see list of accessories, a Simpson LTS12. So what are we talking about here? The designation TJI or LP stand for a form of timber I-joist. The timber I-joist is made by gluing wood flanges to a wood web, and they derive their name because of their cross-section that looks like an eye. They are often used as floor joists and roof rafters because there is less wood fiber in the I-joist than there would be in a solid joist of lumber. They have to be braced because their thin section can make them relatively unstable. The Simpson LTS12 designation is referring to something called a hanger. These devices are used to efficiently connect joists to beams, often looking in this manner to nail or screw one wooden beam to another, and you can see them here. I've included under handouts some catalogs for TJI type joists, Simpson hangers, LP I-joists, as well as something which we will talk about in a minute under the Veterinary Center as LVL, or laminated veneer lumber. So please turn to Veterinary Center sheet S03, and you'll see that this framing for this structure makes use of steel W shapes, what we used to call wide flange beams. And I keep repeating this because you will sometimes see the word wide flange beams or WF, but they mean W shapes. The present use is to call them W shapes, but you'll still find people like me calling them wide flange beams. And you can see all the different sizes: W12 by 30, 12 by 26, 12 by 19, 16 by 26. 12 indicates the depth of the beam, the nominal depth. 30 indicates the number of pounds per foot. And you can see that there are 3 different types of W12 beams, all pretty much maybe 11 and a half, 12 and a quarter inches deep, but of different weights. The different sizes will give a greater load capacity, and that's why they're used in different areas. You'll also notice that there is a reference to an angle, a 4 by 3 by 1/4, and there's a label called LLV. The 4 indicates the length of one leg, the 3 indicates the length of the second leg, and the 1/4 is the thickness of the steel. But what does LLV stand for? Because one leg is longer than the other, which direction do you put the angle? LLV means that the long leg is vertical. So this would be the 4-inch side, this would be the 3-inch side. And then you'll see a reference to 18K4, and we'll talk about that briefly, and a composite steel deck. So if we look at the sheet, we see here is the angle 4 by 3 by 1/4 LLV anchored to the masonry on the side. Here's a composite deck. That is a cold formed steel deck that is laid across these beams and then filled with concrete to form the floor. So, showing you a closer view of it. Here's the LVL. This is a laminated veneer lumber, and it's produced by gluing together dried wood veneers that are about 1/8 of an inch thick. And they are glued together under heat and pressure to create what we call engineered wood. And here again is the call out for the composite deck. Other areas, we have a W18 by 46 wide flange beam. Here's my 18K4. These are the joists that we talked about earlier. So you can see by, as you read it, you can determine what beam or material you need for framing, what size, and where it's going to go. And that ends week 6.